what I think, how you probably think about microservices is, they will help us to scale. We will be able to scale to all our 1 billion potential users right away. We get maximum resilience. If anything crashes, we have other services that keep on running, so our system keeps on running. They will solve all our problems. We will be happy. It's going to be paradise ever after. What I want you to think is a bit differently. I want you to take a different perspective on microservices and ask you different questions. Namely, do microservices help us to better represent our business in our code? Do they work with our team structure? Like our current team structure, or do we have to replace our, restructure? And also, will they make our teams more independent, or will they maybe block our teams a bit more? So, in general, what I want you to take away from this talk is that microservices must fit your technical and your business requirements. And I think that's what we forget a lot when as engineers, because we are technical and we only look at the technical requirements and we forget about all the business side of things. That's what your managers are doing. And the funny thing is your managers, they know the business requirements, but they might not know the technical requirements. So there's a gap. And I want you as engineers to understand both sides of the table. And I would even go further and would say your software architecture needs to fit both your technical and the business requirements. So now you might ask yourself, okay, what are my business requirements? Because technical requirements we can all say, but what are business requirements? And I'm relying my answer and my experience of this talk. I'm relying on my experience, especially with my last company. Job Valley is a German company. And what they do is they are basically a platform like for gig economy. So students, they work with students, and if they want to work, on one Monday to count some clothes, to do some inventory for a company, they can easily find that job through Job Valley. And then companies obviously want to have, some students to just do a gig and then not pay them for all eternity. So that's what Job Valley did, and I had the amazing opportunity to work with two great, really amazing engineers. So Andreas and Ede, if you're watching this, thank you so much for everything you taught me. And yeah, so Job Valley, the company that I worked for before, we had 6 teams at the time, 25 plus microservices. So each team had 3 to 8 services. We had already 2 previously failed monoliths, one of them in Ruby. It was still running at the time, but we were replacing it with microservices. We had a second monolith in Python that was completely replaced by microservices. So they already had experimented with monoliths, decided that is too much of a problem, they moved over to microservices. And I will tell you later why that worked for them really well. And they were 12 years old, and they were an established mid-growth company. So that means they didn't have the need to deploy or iterate super quickly like a startup would have. They had the time to think things through, to plan ahead, to plan long term. Now my current employer, you might have heard the name already, it's called Remote. We're also here at the conference, our VP sitting over there. We have a booth in the back, so if you want to learn more, please reach out to them. We have now, 20 plus teams, I didn't count them, but we have a lot of engineers. We have 1 giant monolith, both on the back end and the front end, so Elixir, and on the front end is React monolith. We are 4 years young and we are still a hyper-growth startup, so very different from the last company. We rather have to iterate quickly, we have to change direction quickly, we have to change our software architecture based on these differences in strategy. All right, so now you look at these things and you might think, well, actually at Job Valley, we had few teams with many services. And at Remote, we had many teams with only 1 service. And if you look into microservices, you might think, one rule that I hear a lot is that if my corporation, if my company grows and I get more and more engineers, I need microservices. Because I can't, it's too complex. It's just, we need it. That's what everybody says. But in this examples, they prove the opposite. And you might think yourself, what's going on here? Right? And the answer to that is bounded contexts and how you enforce them. Now, if you follow me on Twitter, I tweeted about domain-driven design a while ago, and I promised that I would be really irritating about this from now on. So this is my first attack on you. Because bounded context is a domain-driven design, a DDD concept. And basically, if you look at your entire domain, your entire business, then the bounded context are like areas of that business that encapsulate language, models, and rules that is unique to that part of the system. So To give you a more practical example, if you think about a company and you have a marketing and a sales company, and you might ask the marketing team, so how do you define a user? And they say, well, of course, a user is an end user for a product, right? The people who actually use the product, okay? Then you go to the sales team and you ask them, so what's a user for you? And they say, well, obviously, it's the companies that we work with, because they pay us. So two departments in your company, and they have completely different definitions of what a user is. Now, if you imagine, you take these definitions and you write some code and you only have one schema in your code base called user, well, good luck. Because from now on, you will have if-else statements everywhere. If user type is person, do this. If user type is company, do that. And that's going to be a hell of a spaghetti code from now on. So there you already see, if you have these bounded contexts from the beginning, so you have a bounded context for the marketing team, one for the sales team, you separate them in your code, and then from now on you can work on them independently. They have their own rules. Companies can do whatever they want. Like they have some rules for that. We have some rules for people, for users of our companies. Well, I'm saying user, but I mean person. So, you can separate these two things in your code base really nicely. But that's the first step. You need to find your bounded context first, and then you can build your code structure around it. And software architecture is only going to help you to enforce these bounded contexts. And that's what your software architecture should be to you as well. Like you should look at your software architecture and see it as a tool with which you can structure your code. Yeah. So that's domain-driven design, DDD. Now the question is, how do you find these contexts? There are many different methods. One of them that I enjoy a lot is called event storming. And what you do here is you take a whiteboard, digitally or physically. You take a bunch of Post-it notes. They have different colors. And the first one in blue is a command. So if I'm a user and I click a button in the system, that's a command. Like update my profile, save. That's a command. Now what comes out of the command is an event. And that is, for example, user profile updated. It's always in the past tense. So that's what comes out of the command. Then you have the view that I'm interacting with, might be a profile view. Then we have a business process, which is a little bit of a vague concept. But for me, it's something that the system does. So we don't have an obvious actor, but the system has a cron job or an open worker or whatever. Like the system gets triggered and does something. And then lastly, you have aggregates, which is group of objects. So if we have one user, but then we group a lot of users together to like one company or one group, it's called an aggregate. So what you do now is you go and you take a use case in your system. And in Remote's case, for example, we have employees that we employ for international companies. So if you're a UK company and you want to have a Portuguese developer, but you can't hire them directly, Remote does it for you. And you pay us a salary, and then we pay the salary to the employee. And I'm going to use that example here because you as a company that works with us, you need to give us the salary of the employee. So you might do that as a company, like user, and you do that in the employee view. You set the employee salary, and then that's a command, and then out of that we get an event, employee salary set. Okay, now we can do our job, and at the end of the March, we want to pay out the March salary. So we have our business process, like our cron job, or a magical thing that just runs and does everything for us. But if you ever worked in payroll, you know it's not like that. And that has one magical function, which is called payout March salaries, all of them. We use the salary aggregate here because we have all the salaries for all of our employees for the month of March. And then out of that, we have an event called March salaries paid. Okay? Now, if you look at the employee salary set, the event here, the first event, you already see that this is a very special event because without that event, we can't pay any salaries, right? So that is called a pivot event. It's a pivotal event, like it represents a pivotal moment in your process, and only if that event occurs, the process can go on. And usually you can find these events really easily if you look at the timeline of such a process. In our case, the employee salary set event probably happens a couple of weeks or months before we pay the first salary. And then, so you have a month, like a very big gap in time between these two things. And the pivot events are really good markers for separating your contexts. Because we see already that there's kind of like a company-bounded context, and everything the company does is part of that context. And then we have a payroll-bounded context. And if you look at these differences, like the company-bounded context cares much more about the data of the company, about the data of the employees. The employees might have like pretty files like icons, profile pictures, and the payroll context doesn't care about that. The payroll context only cares about the salary and the bank account of the employee, right? So there you already see two contexts, and if we separate them, our system edit will become better, our code base will become better. So now we have the contexts, and another step, the second step you need to take is to think, how do these contexts interact? Because there is a method from domain-driven design which I enjoy, and that is called context mapping. And you look at all your contexts that you identified, and then you see, you look at the relationships between these contexts. So how do they work together? You know, is there like a upstream-downstream relationship? So one team gives data to another team, and if so, you know, how do they, if the downstream team wants to have a change, how does the upstream team, you know, do they implement it? Do they not care about it? All these things. And if you do context mapping, there are like 12 or so predefined relationships you can have between contexts, and I'm going to show you 3 of them. The first one is called the supplier-consumer relationship, and that's what I said about earlier. For example, in my last company, we had a time and attendance team, and they looked at all the hours that the students worked, and you know, they checked that the students worked on the days where they were actually scheduled, that you know, if we scheduled 8 hours, they weren't working 24 hours on that day, so they did some quality assurance there. And the time and attendance team then gave that data to the payroll team. Oh, sorry, I have to talk about context here, not teams. So the time and attendance context gave the data to the payroll context, and then we paid out the salaries based on that data. So the supplier of the data was the time and attendance context, and the consumer was a payroll context. And if the payroll context needed anything, like some extra data or the data in a different format, we could go to the time and attendance context and change it there. So that's the supplier-consumer relationship, because there's another relationship which is similar, but it's a conformist relationship. So in this case, we have payroll, the payroll context, and we pay out salaries, okay? Now the invoicing context comes and says, I need that salary data because I need to create invoices plus our fee. And maybe, depending on your company, this could be a conformist relationship. So that means if the invoicing team needs anything, well, the payroll team doesn't really care. Like they have their own payroll, their own salary struct, you know, and the invoicing just has to work with it. Maybe if they're nice to us, then we're going to change it for them. But if not, you know, it's not a priority. So that's a conformist relationship. And now if you already see here that we have this relationship which might not be great in your company because you want the invoicing team to be independent, to work quickly, to iterate quickly, and they're really much dependent on the payroll team. So maybe we can use a software architecture and a team structure that breaks that conformist relationship. If you would give payroll and invoicing, the two contexts, if you put them into one team, well then it's very easy to change that, right? Because the same team can just update, change the data in payroll and then use that in invoicing. But if you rather want to say, well, we want to strengthen that relationship, then you can also put them into separate teams, and then maybe they have to fight. You know, it becomes more political about that. So that's a choice you can make. Once you understand the relationships, you can think about the team structure of your company, of your department, of your engineering department, and then also about your software architecture as a second thought. And the last interaction that I like a lot is the anti-corruption layer. And this one, for example, we have a time tracking context here, and in there the students punch in their numbers, the hours they worked, and obviously we don't want to trust that, right? Somebody can say, I worked 1 million hours last month, or like minus 10 hours, or like ABC hours, so on. And eventually, some data pops out of that, and the time and attendance team, they need to take the data and check that everything is according to our rules. Like, was the student officially employed on that day? Do we have a contract, you know, that says the student was employed on that day? You know, everything should be legal and compliant. And so the time and attendance context, they don't want to trust the data from time tracking just blindly. They want to add their own set of rules, and if these rules are blocked or if they are false, they throw a warning or they disregard that set of data. So that's why they have an anti-corruption layer, which is like this set of quality assurance you build in. And now if you think already about multiple teams, you know, one team does something, and then the other team, they have to do something really important, like payments. If you think about payments, you know, you don't want to trust blindly any payment request that comes from anywhere in your system, right? You want to make sure that that's actually valid. So these are only 3 possible relationships. And so now we have the context, we know how they interact with each other. Now, last question that you're here for. Which software architecture should I use for for that. Like once I understand how the context look like and how they interact, which software architecture would be good. And in my opinion, but that's really only my opinion, you need a software architecture that, first of all, supports your team in separating the bounded context the best. So whichever software architecture you like that helps your team to make these contexts as separate as possible, that will be good for you. And microservices are great for that because you have a hard boundary between your code bases. You might only communicate through events. You can define these events. You can make sure that they are valid, and you always get the data that you need. So you can really make that relationship explicit. But microservices, yeah, they also need to apply to a second thing, which is it needs to fit best with the organizational needs. Now I mentioned that at Remote we have many, many engineers, and you would think, well, microservices, they would help us best to separate these bounded context, right? But we use a monolith, and we're really happy with the monolith. Well, as happy you can be with the software architecture. We're not excited and raving about it, but we just accept it as it is when we move on. So it's a very German way of being happy about something. Yeah. So you see that the software architecture also needs to fit your organizational needs, right? As Remote, we are hyper growth. We need to change. We need to move on. And whenever we change our strategy of the company, we need to change our code base as well, right? If we do restructuring in the company, we need to, well, ideally, we would restructure our code base as well to reflect that change. And if you have microservices, well, good luck migrating from one microservice to another to replace them and to change your structure there. With a monolith, it's much easier. You just rename the files, move them around, and you're done. So as long as your tests go green, everything's fine. So with a monolith, you're much more flexible with changing. You're much more flexible with reacting to the changes in your business as well. Microservice, not that much. And the last thing, obviously, your software architecture needs to meet your technical requirements. So here's where everything comes together. If you have some technical requirements, like we need to scale horizontally, obviously you need to have maybe microservices to have that load. That's why in my last company, microservices was great for us. We had one team. Microservices helped us best to separate these bounded contexts. Ideally, we would have 3 teams for that, but our practical needs of the company were like, well, we only have so many engineers, so we needed to make it work. And we didn't have any technical requirements that required us to use a monolith, so we could use microservices. In Remote's case, we have a more modular monolith, so we have namespaces per vertical. We call them verticals, like the invoicing vertical and the payroll vertical, and in there we have one or multiple teams. And we have a more modular monolith where we have namespaces per vertical. So invoicing would have the remote.invoicing.mymodule namespace, and payroll would be remote.payroll.mymodule. So this way we can separate our code into these modules, and everything can run in a monolith. So, this talk was very much about abstract things and not Elixir related. So I also put like 2 or 3 slides in to make it Elixir related. So how do you build these 2 microservices with Elixir? Well, obviously for monolith you can just use Phoenix. That gives you a monolith out of the gate. But I'm arguing a lot, if you really build a production system with that, with many engineers, multiple teams, then you might want to go with another software design that we currently have, the MVC design. There are different things here which I only will mention. The onion architecture, the hexagonal architecture, and these 2 together is called the explicit architecture. And I have a video about that on YouTube if you want to watch that. And I also implement something in Elixir according to that design pattern. Then at Remote we have a pattern that our CTO and co-founder Marcelo dreamt up of. He also spoke about that at ElixirConf 3 years ago, so there's a talk about that. He explains much better than than I can do. And we basically have a handler, service value, and finder pattern. We don't have a good name for that, so Hasewafi, Visahava, Havazefi, we still have to find a good name. So Marcelo, that's on you. And useful technologies, if you have a monolith and you want to make it modular or have boundaries in there, obviously there's a boundary library by Sasha Ullrich, I think I pronounced it. And that helps you to really make sure that you don't call from one bounded context to the other. So you really have to go through a public API, and that kind of strengthens the boundaries between your context in your monolith. We don't use it yet. We looked into it. It looks very interesting, but it also takes more discipline from you. Because you need to always add that to your modules and be disciplined about it. And that's something that's very hard to be when you're fast-paced and you have a lot of stress and deadlines coming up, right? So, yeah. Then microservices, how do you build them? In the case of Job Valley, we had Elixir backends. So every microservice was one Elixir Phoenix project, and we had live view for the front ends. So in one company, we had 10 services, so 10 live views basically, and if a user navigate from one tab to the other, we went to the new live view and showed that to the user. There are obvious problems with that. One of them is authentication. How do you authenticate the user on every single live view if you have 10 of them? We use a shared cookie for that. The second one is styling. How do you apply the same styling to every live view? We used an npm package for that we used in our assets folder, and then we only used these classes. So if we updated our styling, then we just updated the npm package, and the microservices pulled that and applied the styling everywhere. Ideally, that's what I learned from this, you have Elixir backend microservices that have an API, and you have an SPA frontend like React, because then you can hide that whole layer, all these microservices underneath, because a React client, they only authenticate once, and then CSS styling is simple as well, because you only have one CSS file. But that only works if you have front-end engineers to do that, which we didn't. Well, we had some, but not enough. If you want to talk between microservices, very good is message queuing. We use RabbitMQ, and that's really good for routing. If you have very complex routes for your events, like one event should go to these 3 microservices, and the other event should go to these 5 microservices, and so on. So that's really good for RabbitMQ. Eventually, we realized Kafka would have been a better choice because it allows replay. And that means if you spin up a new microservice, you can just replay all the events that happened before, and the microservice can consume these events and build up the read model is called, or the database basically. And if you don't have Kafka, you need to ask the other teams to throw all these events again, and that gets really annoying after a while. You can also use Amazon SQS, which I never used, and there's another thing from Azure which I don't even want to mention. So, okay. And ideally, you have standardized deployments. So we used Heroku. Every engineer could deploy a new microservice to Heroku because it was so easy. We had Elixir backend, live view front end, so everything was standardized, Postgres database. I could set up a new microservice in half a day if I wanted to. So that is really important if you want to mitigate the DevOps complexity of microservices. And yeah, we had the same stack everywhere. Now, this is already the end. Let me just quickly recap. First of all, I told you about microservices. I said, hey, you got to look at the business as well if you decide on the software architecture. So we asked, what are our business requirements? Well, in order to find the answer to that, first you have to look at your bounded context, identify them. Then you have to think, how do they interact with each other? And then eventually you have to find the software architecture that supports you by best to separate these bounded contexts in your code base. And if you do that, then you will have a nicely structured code base and you will be set up for the future. Hopefully. There are a bunch of resources. Job Valley published a great article about their microservice architecture. It's in German, but I think you can translate it. There's Microservices in Action, which is written by our VP of Engineering. He sits right there. So if you have questions, please bother him. And there are a lot of other things. And eventually, I would say thank you very much for your attention.
Thank you, Peter. Really great talk. We have a few minutes for questions. We have one there.
Thank you. Great talk. How often do you have event storming sessions? What are the triggers for having one? Who's involved in such a session? And what are the artifacts that come out of such a meeting?
Great question, and thank you. Event storming we did with the teams that were involved. So if you felt, okay, these 2 teams are involved in creating this new context, or there's some vagueness, then these teams will come, the product managers or product owners would come as well. And we didn't have that many event storming sessions. Whenever we developed our system further, then we had these sessions, and they lasted one afternoon, and then we are done. So it also, it speaks to the fact that we had small context, and we really like payroll. Like I only said payroll here, but we had 5 microservices only for the payroll context, because every single one had one specific thing. And we rather wanted to keep our context small so that we can also remove them if we want to, and it's much easier to iterate through them.
Yeah, a couple more. Yeah.
Yeah, thank you for the talk.
Thank you.
I wanted to ask, did it ever happen to you that you had to readjust the bounded context? And if so, how is it easy to reflect this on the monolith and enforce ownership of the new bounded context?
Yeah, great question, thank you. In the monolith, it's much easier. So if you have a bounded context and need to change it, you can remodel it, find the new context you have. And then in the monolith, as I said, you can just change the name of your files, move them around, you're done. With microservices, it's harder. You need to do more like a migration step. You have your old, what I like to use there is a strangler pattern. So you have your old, let's say you have one big context and you want to separate that into two smaller contexts. You replace the big context partially, like every feature you pull out, put it into the new microservice, and then only fetch the data from that new microservice. You do that step by step until you have replaced all the features in the old in the context, and then you can get rid of the old context. That's called the strangler pattern.
Cool, couple more. One here.
Hi, Peter. Thank you for your talk.
Thank you.
I'm wondering if that approach about separating bounded context and so on was your initial idea at Remote from the beginning, or it was just employed at some time. And if at some time, I'm wondering what that pivotal time was and was the conditions, because from what I saw sometimes, it's even though if you don't use microservices for that kind of separation also introduces some kind of complexity and some of tool which you need to overcome to when your business changes real fast.
Yeah.
And you said that you face it hyper growth. That's why I'm curious what's the case for you guys.
I can't really give you a very concrete answer on that because I just don't know. As I said, our VP of engineering is here, so he actually is the person responsible for that. We went through some changes like that in the last year. It can take depending on the size of the change. But okay, better ask the question to Paolo. Thank you.
Yeah, we have time for one more.
Great talk. I did have a question related to, you said your previous job had tried to do or had two failed monoliths. Do you think that had anything to do with Conway's law, where Conway states that your architecture is going to mirror your communication pattern or organization that's building it? Do you think that, or your experience with that had anything to do with that?
I can't really tell you that because I wasn't there when the Python monolith was replaced or when it was in production. But yes, Conway's law, actually I wanted to mention in the talk, and the inverse Conway's law as well, where you use your software architecture to influence the structure of your organization. Great things. I can't, from the top of my head, I can't say whether that was the reason. The reason was rather what I said earlier, that all these contexts were shared in one monolith. And the schemas we had information from all these contexts. So our student schema was 150 fields or something. So that was rather the problem, yeah. But great thing, Conway's law, yeah, your organizational structure influences your system structure. So if you have these departments in your company, you tend to create microservices or parts in your software architecture that mirrors that structure. That's one thing you need to be aware of, and the other one is the inverse Conway's law. So if you change your software architecture and your engineering team structure, you can also influence and support and also work against the structure in your organization. That's something you got to be aware of. Great.
Cool. So yeah, let's give a big thank you to Peter.